learning about the data types and literals. So in it, we till now learned about the need, what is data type, and we learned about the limitation of the primitive data type. Then we learned about array and the array assignment, how the location are being assigned in a array. Then we learn about the limitation of array. Then solution for the limitation of the array. We discovered about the class and how the memory locations are done in a class and what is the class size, how to determine those things, and learned about the size, range, and default values. Then we learned about literals. After that, we learned about primitive and reference type conversion. In that, we learned about primitive type conversion, like automatic type conversion and explicit type conversion. So, moving forward with this video, we'll learn more about the data type, and I am planning to complete the data type and literal in this video only. So, if you want to know what are the things we have learned previously, you can go through the previous videos. Okay. So, like when we doing some casting, so when we are casting, like we are converting from one data type to another, like if we are assigning a bigger value, means a bigger data type to a smaller one data type. So like the compiler will not allow it. Okay, it will tell that we cannot able to put that range of values in it because the range of value that the source variable will have the less than what you are going to assign because compiler don't see the value, compiler only see the syntax. Okay, for that purpose, we require casting. So, like we learned also in the previous video. So, moving forward, like casting, we have the syntax like this. So, syntax will be like this. Why not able to write? Okay, so some problem can also be. Okay, fine for you. Syntax. What all the syntax for casting? So, like this, the destination. Okay, destination data type. Then we will have the variable name will be there. Then equal to here we will be writing the data type of the destination because we want to cast something which we want to cast with convert that data type we will write. Here we will write the destination data type. Okay, then it will be the source type, the variable which we want to change. Source. Okay, this is the okay. This is the syntax. So by cast operation, we are convincing the compiler that the value in source type variable is within the range of cast operator type. And also, we are allowing the JVM to reduce source value to cast operator type if its range is greater than cast operator type. Okay, like in the casting, we are telling the compiler that the destination type here, whatever the destination type is there, here the destination type is a variable. The variable is holding. Variable can hold. The destination type variable can hold this source type value. This source type, whatever value the source type have, this destination data type have the capability to store that. For that, we are telling the compiler on this. And in the case of JVM can see the value. So in the JVM, we are telling that we don't require if this is out of the range of this destination data type. So we are telling to JVM that, okay, uh, the value which is in here, we don't require that much value. If you want, you can cut the value. Or if you can minimize the value, you can less the value up to this destination data type one. Okay, these are the things we're telling. In the example, if we are going to see, let's first write the statement like by using cast operation, we are convincing compiler that the value stored in source variable is within the range in the range of cast operator. Okay, we are telling all this. And for the part of the JVM, here we are allowing JVM to reduce source value to cast operator type if its range greater than the cast operator. Okay, so like we are telling that in this we have int I equal to 10. Okay, we know 10 value can be assigned to a byte value because it's within that range. Up to 128, it can hold. So 10 value within that range. But if you are writing like this, byte b equals 10, it's okay, nothing problem. But if you are writing like this, byte b equal to I, then it is problem. Here, the compiler will throw error. Compiler error will throw. It will tell that this value I range I range will not be assigned. We cannot able to assign the thing because I range is big. How can you assign to a smaller one? Because compiler cannot see the value. Okay. So, but we know internally that it can be assigned. So we will be casting that. Like byte B will be there, then here we'll casting to the byte one, and here I will be I will be casted to byte, and that value would be assigned. Okay. This is the part of the compiler part. But if we are coming for the second point, that the part the JVM does. Okay. Let's say we have this value int I equal to 250. Okay. And if we are going to assign this one, if we are going to assign this one to a byte one, and you are writing here byte, yeah, byte, byte, and we are assigning here. Okay, here what we'll do? Here the JVM will just minimize the 258 and will make it under the range of the byte, and then it will assign to byte variable. Okay, that is a part of the second part. So, like casting is always told as narrowing because data size is decreased in it. Okay, thing. Casting is called narrowing because data size is decreased. Okay, so moving forward, like uh, so we know about the automatic and all those, and we learned about the also the we cannot able to assign a boolean to one integral ones because it will be like incompatible because boolean is true and false, and we cannot assign it true and false to an integer or byte or short or long or double or float. Okay, so like if we come and if we come to isn't that one case is there like char and int. We have the two types up there. So do you think a char value can be assigned to a int one and int value can be assigned to a char one, like the auto conversion or maybe the typecasting, all those things can happen between this. There will be no like incompatible type of compiler will come. I don't think so. I think that no incompatible will come for this. Hi, so we are talking that if int will be assigned to a char or char will be assigned to a integer, then if we get some compatibility issue. So I don't think that we'll get some compatibility issue because char can be assigned to a number type and number can be assigned to a char type. Okay, like here the internal thing which are done by the JVM is that whenever we are just assigning a number to a char one, so the number will be converted to its corresponding ASCII character. Then it will be assigned to the character variable. And in the case of like assigning a character to an integer, then what will happen like the characters corresponding ASCII number will be assigned to that integer. Like this, the conversion will be done by the JVM. This it is able to be assigned in both. So, like I was telling, like by using the cast operator, we are convincing the compiler that the value stored in source type variable is within the range of cast operator type. And we are allowing JVM to reduce source value to cast operator type if its range is greater than cast operator type. These are the things which are for the common things like if you are doing for the number type, for the number like byte, short, int, long, float, double, if we are converting in these types, then these are the required things by the cast operation. But if we are going for this one character and number, then like this, we can assign like character literal to number variable and int literal to character. As I told now, if we assign char literal to number type, then JVM stores that character's ASCII number. And if we assign number literal to character variable, then JVM stores that numbers ASCII character. Like here, the characters are there up to 0 to 9 is there. So according to it, its corresponding ASCII numbers are like this. For up to 48, it will continue to, from 48, it will continue to 57. So for capital A to Z, the ASCII number will be continuing from 65 to 90, and from small a to Z, it will continue from 97 to 122. And we should remember these things. And one thing is like Java supports the Unicode character set. Like it is the superset of ASCII character set. Like Unicode, we have like its range from 0 to 65,535, and ASCII is ranging from 0 to 255. Okay, that's include like this character of numbers is include 0 to 9, then capital A to Z, small a to Z. For some special characters, there uh, like there's at the rate and question mark, all those things. And these things, but I told now this part. If we will go through the example like this, if we are going to assign a number, 98 is assigned to character variable, then internally JVM will convert this 98 to B, like because 98, if we see, sorry, in the small a to z, it starts from 97 and continues up to 122. And so 97 is the small a, then 98 will be the small b. So that's why the 98 will be converted to b, and this small b will be assigned to the character. The ch will be pointing to like this, it will be pointing. So if you are writing like this, we have the statement like this: int I is equal to single quote a. So this single quote a means we know it is 97. The value is that ASCII number. So here the JV will convert to 97, and will replace the single quote a with 97 and it will assign to I. This will be the part. Then moving forward, we will have like we'll have this type of automatic type conversion, like if we want to assign a byte variable to short or int or long or full or float or double or character to int, we can do it, and it is called automatic type conversion. This way, if we are moving forward, okay. And if we are moving backwards, like double value, if we are assigning to float we are assigning to long, then we need the help of casting, as we read earlier. Okay, and Boolean is different. And if you are assigning Boolean to any of these number types or characters, then we will be getting incompatible issue from the compiler. Okay, now moving forward with the reference type conversion. So, like one in this reference type conversion, like assigning one class object to another class referenced variable, which is called reference type conversion. And to perform reference type conversion, the two classes, this is the important point we should remember like this. To perform the reference type conversion, the two classes should be compatible. Okay. The classes become compatible. So when the classes become compatible, the classes will become compatible only if they are developed with inheritance. So we have noted learned about the OOPS concept. So later on, even we are going to learn the OOP concept, like the object-oriented programming concept of the Java. There we'll learn about the encapsulation, inheritance, polymorphism, and abstraction. So till now, just learn that inheritance relation is called a EJ relation, like superclass, subclass. We have EJ relation. Like we can say that is a father and son is there. So he is a son of him or her that we are telling. He is a son. So the child is the subclass and the father is the superclass, like that. So inheritance will be there from father to son, EJ relations that we call. If those classes will have a EJ relation, then only we can able to do the reference type conversion. So if you are going through the notes one, guys, there is like construction work is going on in my area. So sometimes you will be hearing some peculiar sounds behind. So don't worry about that. But my voice is more pitcher than that. So I will try to nullify that. but still we can hear the sound, but don't concentrate on that. Okay, like assigning one class object to another class referenced variable is called reference type conversion. Okay, and to perform this type conversion. Okay, conversion the two classes between the two classes whom we are doing the type conversion. Those two classes could be compatible. And when the classes become compatible, now I told it will be compatible when there will be a relation between them as a inheritance. Means each relation will be there. So the classes become compatible only if they do not with the inheritance is called EJ. Okay. So up to this part we are clear. Okay, like we can tell like this. We are writing like this. This is a class. Test is there. Okay, then another class will be like this. Class test one extends test. Then there is okay. There is extends when it's coming from the inheritance. We do either through extends or through implements. Okay, like this we achieve the inheritance. So achieve extends and implements. I already told that Java is nothing but English language only. So English language extends or implements something coming out of it, extending. Something is there and we're extending out of something. So it is that inheritance and implement. We are implementing something. Something is there already and we're implementing something. So while the class which is implementing, that is a subclass, and that the class which is extending, that is a subclass. So like here the test one is a subclass of test one is the subclass of test. Okay. Like we will be here like interface I1 will be there and we have class example implements I1. So like here example subclass of I1. Okay, so these are the things. So moving forward, like more about this extends. Extends is like inheritance between two interfaces or two classes. Okay, the between two interfaces or two classes. Okay, and implements Relation between interface and like here we can say like interface I1 extends I2. And in the above we saw that extend is done between two classes. Okay. And implements we have saw also. That is above one. Okay. This one, this one, this one, this one, this one. Okay. So moving forward, uh, the class that is placed after extends keyword is called superclass, and the class which is present before that it is called subclass. Like here, test one is the subclass. Okay, and test is the superclass after extends. This one is there. So also this one after implements this one. So it's the superclass. Before implement is the subclass. Okay, like this. Before sub one, after super. Okay. So if the classes are there like this, class sample will be there, and class test will be there. Class test will be there. These two have no relation. Sample and test have no relation. So these two are called siblings. There is no relation between them. Okay. So going forward with this. So what are the classes? Means which are the classes called compatible? Okay. Sorry. These points which we are going to now are important. So which are the classes compatible? So like can say subclass is compatible with superclass and superclass it's not compatible with subclass. We cannot convert this. Okay, like Boolean and those Boolean and number type in the primitive. So superclass is not compatible with subclass, but subclass is compatible to superclass. We can assign a subclass to one superclass reference variable, but we cannot able to assign one superclass object to one subclass reference variable. Okay, so and obviously siblings are not compatible. Okay, so these are things. So remember, not remember, just practice. These things will be remembered automatically. Practice the things. So you're remembering a lot. Okay, what is the assignment? The rule is what is the right assignment between the reference type? So the rule we should check in reference type conversion is source type is a destination type or not. Like source type, whatever source type we have, that is a relation with the destination type or not. Okay. So we can assign the subclass object reference to a superclass reference variable. But like I told just before the question. So, but superclass object reference cannot be assigned to one subclass reference variable. Also, sibling object reference cannot be assigned to another sibling class reference variable. Okay. The rule we should check in conversion source type is a or not. Okay. This may be a small sentence, but it will have bigger meaning. I think calibre will be better. Okay. Let's take an example. Class A is there. Okay. And we have class B extends A is there. Okay. So here, like here, if we have int A equal to 10 will be there. Okay. And here, int B is equal to 20 will be there. Okay. Like this, it will be there. Okay. And we have like this, and we have assignment like this. A equal to B will be there. So if we are able to in this A reference, we can able to access like A, we can access. It will give us 10. But if you are going to access like this A dot B, okay, then like the compiler will give error. It won't able to find because in this we will understand about the compiler algorithm here. Like compiler will in this statement, like compiler will try searching for B variable in A class, but it will not able to find. So it will give error like this. That's not because compiler never goes to compiler never goes from superclass to subclass for searching in one variable. Okay, this is the compiler's algorithm. You should know these things. It will be very much useful actually. Okay, this one. So if we are going to write like this, so like B equal to B will be there, and B dot B, it will give us 20. It will compiler search in the B reference class, that is B class, and it will get 20. And if you write this B dot A, then what will it? It will give compile time error? No, it will not. It will give us 10. So here the compiler algorithm is that whenever we are writing A dot B dot A, then the A variable the compiler will search in the B class. Okay, in the B class. It will not found here. But in the class, in the first line, that what is written? B extends A. It's written B extends A. So it will go to the extends A to the superclass. So in the superclass, it will find the variable and it will give us the value. But no such things is written here. So that's why compiler, if search here, like in this case, search for B variable not found, give error. But here extends A is written now. So it will go to this class. It will get the 10 and then return. Okay. Compiler will search in big class, if big class is not found, then we'll go to the class by the by extends. We'll found a variable there. And we'll keep okay. Okay. This one was for this. So moving forward. So like as I told, from this we got one thing. So we can assign subclass object reference superclass reference have but superclass object reference cannot be assigned to and also like siblings cannot assign also. Okay. Like if we'll assign like this from the top, either B is the subclass. So if I'll do like this, B equal to name. So let's see. But internally, phi we cannot assign. Phi it is a round one. Okay. This is a round one. Okay. Because like this. So for this part, a memory will be created for B. Okay. It will be created for B1. Okay. Then for the part of this one, new A is there. Okay. Here the new A is there. Okay. So one object will be created. One object will be created for A. Okay. It will be created for A. Okay. It's good. But inside it, inside this object, inside this object, every inside this object, there will be like every class contains it superclass memory. No class, no class object In Java, no class object contains subclass memory because as we know, Java is deriving from the real world example. So in the real world, like does a father contains the memory of a child, memory in terms of the genes, all those things I matter. Okay, not like the memory of the child playing and all those things that things that I'm not telling. But the thing is, but the thing what I'm telling is like our face in our face we have the memory like we have the nose, eyes, forehead, hands, our skin color, our talking and our behavior, all those have so the memory of our father or our grandfather or maybe our four grandfather, all those memory will be stored in us. Means a class object will contain its superclass memory. Okay, like our father will contains the genes of his father and his forefathers, not the genes of ours. Okay, like that thing only. So like here A, as we know, the superclass of all the classes is object class. So it will contain the memory of the object class. Okay, this will be the object class. Object class memory. This one. Okay. So here nowhere we can find the B class object. Here we cannot find B class object memory. So how if he is not present, B class memory of memory is not present, then how this B reference variable will point? Whom it will point? Either it will point to its same class or maybe subclass. Okay, it is not there. So whom it will point? That's why the mapping will not be done here. That's why the linking will not be done here. That's why the compiler will throw error and it will is like it will like incompatible. Okay, and we, as we know that siblings like their siblings we know that like object will be like here there will be like object for test is there. Okay, we must cross this one. Object test is there. So if we have a variable of a reference variable will be there. So it can it be pointed? No, it cannot be pointed because in the test class object there is no memory for age. So how can it be pointed? It will not be able to point it. Okay. If you like this A is equal to new test, then this is wrong. Okay. Let's say wrong. Okay. So up to this much we will read today. So in the next class that will be final class, as we are not able to complete today. So next class will be reading like this, like types of reference type conversion, like upcasting, downcasting, how it is done in case of the reference variable, and like class cast exception, how we are getting class cast exception, when we will get the class cast exception, and how to stop the class cast exception using the help of the instance of operator. What is instance of operator? How to use those instance of operator and when we should implement upcasting and downcasting in project and limitation of upcasting, what is there and what is the need of downcasting and like is Java is 100% 100% object oriented programming language or not. Okay, that thing we'll learn in the next session. Up to then, thank you. Bye.